Welcome back. South Africans can breathe a sigh of relief. Eskom says it won't be implementing load shedding while it rebuilds a silo at its Majuba power station in Mpumalanga. Now, the power giant says despite regular checks and maintenance, a crack developed in the coal feeder, causing the collapse last weekend. The plant is currently operating at 60% capacity.
The lights will stay on for now. And yet again, South Africans are being urged to conserve power.
Living lightly is one that we really would like all South Africans to take on board. Is that the system is now more vulnerable to variations, more vulnerable to extreme weather events. And that means that the more we can reduce the demand for electricity, the more we can have available to absorb those extreme events.
Last week, Silo 20, which supplies Eskom's Majuba power station with coal, collapsed. Amid allegations of aging and unreliable infrastructure, the power utility insists this was an isolated incident.
The silo was inspected, is inspected every 2 years. The last inspection was in September 2013, and it showed no signs of any deterioration or structural damage based on the inspection at that time.
Rebuilding the silo will be no easy feat. It's expected to take up to 24 months to complete. In the meantime, mobile conveyors have been installed to keep Majuba supplied with coal. Narissa Subramani, Johannesburg.
Well, it's been a difficult week for Eskom, with the parastatal struggling to maintain a stable power supply. Once again, some are asking if government is seriously looking at alternatives to coal-fired power stations. Well, for a look at some of these alternatives, we're joined now by the Chief Executive Officer of the South African Wind Energy Association, Johan van der Berg. Johan, thank you so much for coming in this afternoon. Firstly, let's perhaps demystify the issue of wind energy. How does it all work?
It's actually very simple. We've got many wind pumps in South Africa that use the power of the wind to turn the wind pump that pumps the water, and in this case all we do is we ultimately convert that mechanical power into electrical power, and it's really as simple as that. What is different is that the wind turbine is significantly bigger, so it's about 100 meters high and the blades are about 50 meters long.
What is the feasibility of looking at wind energy as an alternative source to coal?
Well, extremely good. We've got a wind atlas in South Africa that has been compiled, and it shows that we can build a great many, something in the order of maybe 5,000 wind turbines and more in South Africa over the next 20 years.
But I assume that the challenge is there is that it's all up to the climate. So how do you gauge whether or not you're actually going to have enough wind to supply energy?
Very good question again. So you have a rough indication from the wind map of South Africa, but then you measure for a good 12, sometimes 24 months, and then you look at the months for the years for which you've measured, and you go back in the record and you say, well, were those windy years or were they quiet years, and you normalize that reading over a 20-year period, and you get it guaranteed by an international expert, so it's extremely accurate normally.
And what fraction would wind energy actually be able to alleviate pressure off Eskom, for instance? How much power could one realistically rely on, factoring into, of course, climate change and all of those issues?
According to the energy blueprint for South Africa, which is called the Integrated Resource Plan, by 2030 we'll have maybe 9% of penetration from renewable energy, of which wind will be a good proportion. We think it can be significantly upscaled, and my own expectation is that if we really work hard, we can get up to 15 or 20% of wind power by 2030.
What are the implementation costs?
Well, the very good news is that if the government decides to build any power station, be it coal or otherwise, ultimately it pays as we go. In other words, you have to pay for the capital and then obviously the electricity, whereas if the private sector builds, which is what's happening most often in wind power, you don't pay, you only pay for the electricity. And on the unit cost, in the fourth round of bidding that we've just had, the lowest price was 56 cents per kilowatt hour, whereas the Medupi power will probably cost 105 cents per kilowatt hour. So it's the cheapest source of bulk electricity we have available now.
And just lastly, in terms of the issue of investment, when we're looking at how much government should be investing in alternative sources of energy, whose responsibility is it really to be identifying those alternative sources? Is it government, or is this the responsibility of ESCOM?
No, the sources have been identified, and there are literally dozens and dozens of projects that could roll tomorrow to alleviate our electricity shortages that we're likely to have until about 2020. And it's all really just the issue of government making the decision to roll it out, which they have done, and then the second question of how quickly they want to roll it out and how ambitious they want to be about it.
And lastly, when you look at the power situation in South Africa currently, do you think it is likely that we will continue to see the situation of rolling blackouts, especially as we wait for power stations like Kusile and Medupi to start supplying energy?
The best information we have, that's also been repeated in Parliament, tells us that we'll be electricity constrained until about 2020 to a greater or a lesser degree. The renewable power will definitely make a difference to that.
All right. Thank you so much for coming in this afternoon. That was Johan van der Berg. He's the Chief Executive Officer of the South African Wind Energy Association. Now, the